Hello everyone, this is Dr. Geetha Yadav working as Assistant Professor in CSC Department at Mlritm. In today's session, I am going to explain about K-means clustering. Before going to the K-means clustering, let's have a glance on the clustering. So clustering is unsupervised machine learning technique which is used to similar data items without using unlabeled data. It helps to discover the hidden patterns or natural grouping in a data sets by placing the similar data points into the same cluster. So here in clustering, we are going to group the similar data items based on a features. It may be a color or a texture, or it may be any other characteristics. So we are discovering the natural grouping or unstructured unlabeled data without any predefined category. So here we are going to categorize the item that which are unlabeled. So the data is not labeled here. We are going to find out an item and we are going to categorize them into a category. And data points are assigned to a cluster based on the similarity or a distance metric. Here we are finding the similarity of an object based on a distance metric. It may be a Euclidean distance or it may be a cosine similarity, or it depends upon the type of clustering method we are used. So this is a practical example where you can see a basket where it is having a full of apples, like a pink color or green color or any different color. So what we are going to do is, now we are going to group them into a category, right? Like it is into a red category or a pink category or a orange category or yellow category. So now in this clustering, like what are the different types of fruits they have given, we are grouping them into a similar item, that is like based on a feature called as a like color we are using, right? So here we cluster the items based on a similarity. So what are the different types of similarity we are going to observe is, like we are going to group them based on similar properties. So here in this similarity, we are having the two types of clustering. One is your intra-clustering and the other one is your interclustering. So in the intra-clustering, like we are grouping the similarity among the data points within the same cluster, whereas in the intersimilarity, we are grouping the items on different clustering. So you can see the example over here, that is your intra-clustering, that is the items are present within the cluster. You can see the distance, like the arrows, the double-sided arrows which is giving a distance, like there the differences will be low and the similarity will be more. Within the intra cluster, the difference will be more, right? We can find that there will be a maximum of similarity, and here in the interclusterity the distance will be high, and and you can see the like it is different between the different clusters. So we can say a good clustering, it is having a low intercluster similarity and a large distance between the clusters. And in the clustering, we are having two types of clustering. One is your hard clustering and the other one is your soft clustering. So hard clustering assigns each data point to exactly to one cluster, that data point should not belong to the multiple cluster, making a grouping similarly, that is only a single data point belongs to a cluster, that data point will not belong to other type of a clusters. So here each data point must be belongs to only one cluster, and there should not be overlap between the clusters, and simple and easy to interpret. Since a data point is belonging to only one cluster, then there will be a no overlapping. We can directly define the data item which cluster it belongs to. Next, coming to the soft clustering. So here in the soft clustering, a data point may belongs to the multiple clusters with different probabilities. So we can say that a particular data point like 1, 1, it may belongs to the C1, and the other one may belongs to the C2. The same data point may belongs to the cluster 1 and the cluster. There the probability difference of the items will be different. So if it is for a cluster 1, there is a 70% of probability, and the second item, that's 32% of similarity is there. So here a data point is belonging to the two type of that will be defined, and that can be traced by using a different Euclidean distances or a cosine, that will be finding the if it is having a similar more data probability, then we'll be taking that data item. Now we are moving into the topic that is your k-means clustering. So k-mean clustering is a centroid based partitioning clustering algorithm. So here we are considering a point called as a central point, that is called as a centroid, and here we are going to build an hierarchy instead. Like we take a data item based on the particular cluster. So based on that kind of a feature, we are going to identify the natural groups on unlabeled data setters and working this by distance to a center clusters, and commonly used, like where are we using this k-mean clustering is in the cluster segmentation or image compression and a pattern discovery. And we can find that you can see the before k-means there are different sort of an objects over here. After k-means you can see that there are the different clusters, like a orange cluster, a pink, a green, or a different set of clusters are grouping. After that is based on a similar color. So here k-mean clustering, where k represents the number of clustering, means represent the centroid based. So we are doing a clustering based on the centroid. So we'll see how a k-mean cluster works. So you can see, like if they have given some data set item with some certain features and some certain values like a vector, then what is the task is we have to group them into either to a cluster 1 or to a cluster 2. So in order to do this, we have been used a k-means algorithm. First we'll take one k. So if we want to assign a clusters as 3, so the value of k equal to 3 here. K represents the number of groups. So here we can see the diagram. So first we'll go for a different types of steps here. One is your initialization. So we are going to take the k number of cluster. It may be a 1, 2, or 3 based on the kind of a data items. Then we are assigning that step. In that we are assigning to a nearest centroid. Then after assigning that particular centroid, again we need to go for an update state. Like recalculation is needed for a centroid to find out the particular value, and iteration. Like we have to repeat the steps until there is no or like a repetition of other centroids, or the same value should be there. It should not be changed. And like we can see this visualization either by applying your PCA, like your principal component analysis, for 2D or 3D visualizations. Now I'll explain you the initialization phase. So here the first major step is like we have to pick the value of k. Like if it is based on 10 items or 15 items or 30 items, based on that we are going to take a value. Like if it is a 10 items, I have selected the value of k equal to 2. Now what we have to do, and after assigning this initial, like taking the k value, now we have to pick the k random splits. Like what are the data points you want to. So now I'll select the 2 data points as your centroids, and what we have to do is like whatever the other data points, like from 3 to 10, whatever the data points which we are having, we have to suggest the guesses and we have to calculate the centroids to that. So how to calculate this? So first we have to take some random points, then we need to calculate that to a different data points. Next is your cluster assignment. Now whatever the data points which we have taken, now we have taken 2 data points, right? In that the data point has to be calculated a Euclidean distance. Now we'll calculate that Euclidean distance with 2 random points, and after calculating the 2 random points, whatever the distance which is having a lowest value, that data item will be taken into that particular cluster, either to a C1 or a C2 based on the distance. So here the distance metric which we are using is Euclidean distance. That is the formula x2 minus x1 whole square plus y2 minus y1 whole square to the square root. So this is the Euclidean distance formula we are using in order to calculate a data point to a particular centroid. And for that, like whatever the data points which we are having, for all the data points we need to calculate the distance for, to a cluster 1 distance and to the cluster 2 distance. If that particular points are moving on, and we have to assign the different data points to based on the distance. So here the lowest, whatever the value which we are getting a lowest value, we'll take that and define finding the minimum distance. This process repeats for all the data items until the complete data set has done. Now centroid update. Now what we have done in the first step, we have been calculated the Euclidean distance with all the data points, and whoever the distance is low, now we have grouped the data point into other cluster. And similarly, we got some data points to a C1 cluster and C2 cluster. Now what we have to do is, now we have to, we need to update the centroid. That is, whatever the points, if it is a C1 cluster is having like 3 data points, whatever the data points which have been taken, we have to calculate the centroid. So if it is having a 3 data points, what is the formula? X1 plus X2 plus X3 by 3, comma Y1 plus Y2 plus Y3 by 3. This is the centroid formula we have to use, and we have to update the centroid based on the cluster 1 and a cluster 2. Now we got a new centroid, right? Now the centroid, whatever the point we have been initialized or we got it from the calculation, again that centroid is your new centroid. Again the process has to repeat from the starting. Now the data point to the centroid, again we need to calculate the Euclidean distance and to all the data points. After that you will get a similar values, right? Now centroid C1 and C2 we are having. Now what we are doing, X1 to the C1 we are calculating and X1 to the C2 we are calculating. The same, the whichever the distance is low, now the X1 data point will be moving to C1 either to S2 S2 based on the distance. So this is how we are going to move to the next step. So centroid update will be done whenever the cluster has been completed his complete data set passes, right? This is how the centroid update will be done. Now the convergence, whenever this loop begins, that is now again the starting process with the data points to the centroids we have been calculated and we have been moving, right? Now this centroid will be stop shifting only when then there is a perfect center. So how can we say that there is a perfect centroid? Whenever the value remains the constant, that value will not change, then we can take it as that particular point as the last value, or we can say a perfect center for that particular points will be taken as a clusters. How a working of a k-means, and an example you can see, the first point is selecting the k. Now we have to choose the complete k-mean clustering algorithm in a single diagram. So select k. So we have to choose the number of clusters, and k represents the number of centroids, like whatever the data points we have been taken. So firstly we have taken the 2 data points, that is will be C1 and C2. Next will be initializing the centroids, and randomly we are taking that centroids and we are calculating the Euclidean disturbance, the data distance for each data point. Next to that particular third point, assigning each point to the nearest centroid. Now after calculating that, what we have to do, we have to group the data item to a cluster. After that we have to update that particular centroids as the mean of all data points, and we have to repeat this process until there is no, or we can say that the value will remain same, or no longer the value is changing. This is how the process is repeated till the value is not changing. Now we can see the numerical example of your k-means clustering. So you can see here the x point and a y point. The p1 1 comma 2 and p2 2 comma 1. They have given some data points. Now here they have taken c1 and c2. That is 1 comma 2 as one centroid and c2 is 5 comma 1. Now first, we need to choose assign the values. Next we have initialize the centroids. After that, what is the value of k here? K equal to 2. Now what we have to do, the third step, for each data point we have to calculate the Euclidean distance. You can see this is a point and this is the Euclidean distance to a C1 and a C2. You see point 1 comma 2 D1, what is the distance we got? 0, and we got 7.21. You can see the difference over here. For the P1 point the difference is 0, and the P1 point we got the difference is 7.21. So what we have to do, the point 1 comma 2 has to move to the cluster 1. Similarly, you can see the other points here, 2 comma 1. Now we have been calculated the Euclidean distance. So Euclidean distance should be calculated for the data point 2 comma 1, whatever the distance we have taken the cluster distance 1 comma 2. Now the difference is 1.41 and the 7.60. You see the difference is the 1.41 is the smallest distance. So the data point is moving to the cluster 1. Now you see the third point 4 comma 7. So D1, what is the Euclidean distance we are calculating here? Now with the 4 comma 7 and a 1 comma 2, the distance is 5.83, and the other distance is like 1.41. So cluster 2. And similarly for the point 5 comma 8, now we have been calculated with 1 comma 2 and we got the distance as 7.21. And similarly with the data point of 5 comma 8 and the other data point 5 comma 8, the distance is 0. So whatever the distance is here low, that is 0. So cluster 2. Similarly for the point 6 comma 7, the distance has been calculated and you see the cluster is moving to the cluster 2. So you see here the C1 cluster C1 is having a point P1, P2 and the cluster 2 is having a for like a P3, P4, 4. Now what we have to do, the other step is we have to recompute the centroids. How to recompute the centroids is like a C1, like I have said you the formula, right? X1 plus X2 by 2. So Y1 plus Y2. So 1 plus 2 by 2, 2 plus 1 by 2. So it's 1.5, 1.5. The new centroid is 1.5 comma 1.5. The other point cluster 2 points is 4 comma 5, 5 comma 8 and a 6 comma 7. You can see this like x1 plus x2 plus x3 by 3 and x1 y1 plus y2 plus y3 by. Now the point is 5 comma. So now the new centroids here we got is c1 comma c2. What is the process we have to do? Again we have to recompute the process with p1 to p5. All the points we have to compute with a new centroid. So now the point will be 1.5 and the other point will be 5.5 comma 7 point. For this we have to again calculate the Euclidean distances. Now you see the distances between these points to a centroid. So now you can see the point 1 to a new centroid 0.71 is less when compared to the 6.6 and point 2 0.71 is less 6.42. Now similarly, so 0.41 and 0.41 are the less values or low values when compared with the 6.6. So we are moving into the cluster 1 and similarly you can see the values like 1.05, 0.67 and 1.05 are the values less when compared with this P3, P4 and P5. So we are now changing these values to are assigning it to a cluster 3. So what are the clusters we are having? You see again we have to update the centroids, right? So what are the centroid points we are having? 1 comma 2, 2 comma 1. So the points are similar and cluster 2 will be the points P3, P4, P5. So the centroid value we got it from the previous centroids and these centroids are same. So what we can say, now the centroid values are not changing. So this is the final cluster points and the cluster points P1 and P2 are belongs to cluster 1 and cluster 2, P3, P4 and P4 are belonging to the cluster 2. This is how the k-mean clustering works and you can see the final results here, like we are taking cluster 1, cluster 2, centroids and a centroid 2. So centroid is a x point we are taking and x is like other x centroid 2 we are taking. So the C1 cluster, whatever the centroid value is 1.15 and what are the points we are taking and the final results you can see the centroid 2 and the other 3 points. So in order to calculate this kind of a value, we are using a Euclidean distance formula and with like common differences. So how a particular k-mean clustering works. So now we have seen the k-mean clustering where actually the k-mean clustering works. So k-mean clustering we can be given in a real-time examples like your data segmentation or like any sort of Amazon site or any like if you want to find the behavior or if you want to find out the similar items chosen by a particular people. So data segmentation is one of the most common use or like for example like a business where you use the group the customers based on the behavior like a pattern, like what are the different kind of a patterns they are buying or like a website like what are the Amazon or what are the different types of items. Like if we take an example like a person buying like a similar kind of an item, if I am buying a pen, if other person is buying a pen and like he buy like he has chosen some other type and like he may like the other person may recommend me, Amazon may recommend me the this kind of items may be suitable. It's like a k-mean clustering will be helps in a recommendation and other side of things will be done. Like and here it is also used for image compression. So you can see the k-means clustering where you can reduce the complexity of your images by grouping the similar pixels like into a clusters. Like here in this we are going to take some features like what are the like image storage or processing, like a similar color items or like a similar groups or similar items. Like image compression is done with the help of this k-means clustering. Next is anomaly detection. So like any sort of outliers within like outliers outliers, we can say that the points which are outside the clusters are are called as clusters, are called as outliers. That can be identify the data points that do not belong to any of these clusters. So we can say that these are the different types of clusters. Like it is used in real time examples for finding a similar behavior, color matching, or like a pattern, or like we can go for a mark prediction or behavior, or any sort of a things like a percentage highest like a marks in a class, or like what are the similar behaviors, or like a similar grouping of items. Everything like it can be used in market basket and as all kind of things. This kind of a k-mean clustering works. Thank you.